So hello my dear viewers, I'm glad now I brought to you section 2 of mathematics paper 1 Kcse 2023. So section 2 from question 17 all the way to question 24. So stay tuned to the end, and please, if you haven't subscribed, consider to subscribe, share to your friends and colleagues. Also remember to drop your comments on the description below. Thank you so much as you stay tuned. Begin with question 17, and question 17 reads: two towns A and B are 400 kilometers apart. A motorcyclist traveling at an average speed of 60 kilometers per hour left town A for town B at 1:20 p.m. A matatu traveling at an average speed of 80 km per hour left town A for town B at 2:00 p.m. Calculate the distance covered by the motorcyclist by 2 p.m. Roman 2. Distance from A in kilometer where the matatu caught up with the motorcyclist. And Roman 3. Time when the matatu caught up with the motorcyclist. And part B of question 17, a lorry traveling at an average speed of 40 km per hour left town B for town A at 2 p.m. Determine the time when the lorry and the matatu met. So part of the question, we need to calculate the distance covered by the motorcyclist by 2 p.m. So we have two towns, from town A to town B. So, and it is 400 kilometers apart. So a motorcyclist traveling at an average speed. So we have a motorist, cyclist, so it's traveling from A to B and the speed is 60 km per hour, and also left turn A for turn B at 1:20. So the time the motorist left, it was at 1:20 p.m. Then also a matatu traveling at an average speed. We also have a matatu which is also moving from A to town B. So the speed is 80 km per hour and left for town B at 2 p.m. So that is the time the matatu left. So part of the question, so calculate the distance covered by the motorcyclist by 2 p.m. So we need to know that from 2 p.m. and 1:20 p.m. the difference in time is actually 40 minutes. So 40 minutes, but this is the same as 40 over 60 hours, a fraction of hour. Then so the distance covered, so the distance covered in 40 minutes, we know the speed of the motorist. So the distance is given by speed times time. So the speed of the motorcyclist is 60 km per hour, and the time, so you have to give the use the time in hours, so that will be 40 over 60 hours. So by 61, so the time will be so we end up getting 40 kilometers. So that is the distance covered by the motorcyclist by 2 p.m. Then part B, Part A of Roman 2. Distance from town A in kilometer where the matatu caught up with the motorcyclist. That is distance from town A in kilometer where the matatu caught up with the motorcyclist. Now, what I want you to note is that from town A to town B. So what is the difference in time or difference in kilometer from where the matatu? So by 2 p.m. So by 2 p.m. By 2 p.m. the matatu was at this particular point, and I mean that is the motorist, and then the matatu was at point A. That was by 2 p.m. So by 2 p.m. and you know that the motorist had cover a distance of 40 kilometers. So to get the time distance from A where the matatu met, so they must be able to meet at a certain point. So, and to get a time taken to meet is given by the distance between the two vehicles, distance between them, and also we get the relative speed. So by 2 p.m. the distance between them was 40 kilometers, as we have got in part Roman 1 of part A. And then the relative speed, since they are moving in the same direction, we get the difference in speed. So 80 minus 60. 80 minus 60 kilometer per hour. So we end up getting 40 kilometer divided by 20 kilometer per hour. So this will be 2 hours. So from 2 p.m. they will meet after 2 hours. So they will meet after 2 hours. And therefore the distance from town A in kilometer. So to get the distance from town A in kilometer, now we are considering matatu left from town A up to the point where they met. So the distance from A when they met will be speed times time. And in our case here, it's after 2 hours. So matatu left from town A at a point where they meet, what is the distance covered? So speed of the matatu is 80 km per hour. We multiply by time after 2 hours. That's when they met. So this will be 160 km. So from town A. So they'll meet 160 km from town A. Move on. Part A, Roman 3, time when the matatu caught up with the motorcyclist. The time when the matatu caught up with the motorcyclist. So, we have seen that the time after 2 hours, that is when the matatu was able to overtake caught up the motorcyclist. So, from 2 p.m., so after 2 hours, we add 2 hours. We are going to get, that will be 4 p.m. or in 24 hours clock system will be 1600 hours. Then part B of the question, a lorry traveling at an average speed of 40 km per hour left town B for town A at 2 p.m. Determine the time when the lorry and the matatu met. So, still from town A to town B. So a lorry traveling at an average speed of 40 kilometers left town B. So the lorry left town B towards A, and the speed was 40 kilometers per hour, and that was at 2 a.m. And then determine the time when the lorry and matatu met. And matatu left town A. Matatu left town A at 2 p.m. and it was traveling toward B, and that was the speed was 80 kilometers per hour at 2 p.m. So they left at the same time. They actually left at the same time. So we need to know the time it took for them to meet, the time it took for them to meet, and the distance from A to B is 400 kilometers. So time taken to meet is distance between them, distance between A and B, all over relative speed. So distance between A and B is 400 kilometers, and the relative speed, since they are moving in opposite direction, we are going to add the speed. That will be 80 plus 40. Therefore we have 400 divided by 120. So this will end up getting that will be 3 hours and 20 minutes. But the question is, determine the time when the lorry and the matatu met. So from 2 p.m. after 3 hours 20 minutes, that is when they met. So we add, so by 5:20 p.m. that's when they met, or in 24 hours clock system will be 1720 hours. On the following grid, triangle PQR is drawn. Here is the triangle already drawn with the scale given. Therefore, but on the same grid we need to draw triangle P prime Q prime R prime, the image of triangle PQR under reflection in the line y is equals to 0. So what we need to know here, where the line y is equal to 0, that is actually the x-axis. Y is equals to 0 is normally the x-axis, and therefore we need to locate PQ, P prime, Q prime, R prime. So that means P, which is, okay, so here P is 1, 2, and then Q is 2, 1, and R is 2, 2. So it is mapped to P prime, Q prime, and R prime. So now this triangle, when reflected in the line y is equals to 0, that is the x-axis. Remember properties of reflection. The image distance is equal to object distance, and they are perpendicular to the line, mirror line. So from here, Q prime will be at this particular point. It will be Q prime. Then R prime will be R prime, and then P prime will be at this point P prime. Therefore, we can be able to join the point together. So joining the points P to R and then R to Q, P prime and P prime to Q prime. So that is that is a triangle P prime, Q prime, R prime, and this is the mirror line. So this is our mirror line. Then the other Roman 2 triangle P prime, Q prime, R prime, the image of P prime, Q prime, R prime under an enlargement scale factor. So under an enlargement scale factor, this scale factor is minus 1.5. Actually it is given, and the center is 0. So the center is about the origin. So we need to get P prime. So to get P prime, actually it will be the scale factor times the coordinates of P prime. So that will be minus 1.5 times the coordinates of P prime, that is 1 minus 2, 1 minus 2, Q prime is 2.2 minus 1, and the other one is 2 minus 2, 2 minus 2. So multiply by 1 minus 2, so we shall get, that will be minus 1.5 and 3. So that will be the coordinates of P prime. For Q double prime will be minus 1.5 times the coordinates of Q prime, 2 minus 1. So we end up getting the coordinates will be minus 3 and then 1.5. And lastly, R double prime will be the scale factor of minus 1.5 times R prime is 2 minus 2, so the coordinates will be minus 3 and 3, minus 3, 3. So since we have the coordinates of P prime, Q prime and R prime, now we can be able to plot the points. So let us plot the points. So P double prime is minus 1.53, minus 1.53. So that's where P double prime is. Then Q double prime minus 3, 1.5. So that is the point. Minus 3, 1.5, that is Q double prime. And finally R double prime is minus 3, 3. So that is it. Therefore we join the points. So this is R double prime. So let us join Q double prime to R double prime, R double prime to P double prime, then P double prime to Q double prime. So that is the triangle under the enlargement. So the image of what? The image of is triangle under that enlargement. So the center, origin, that is what we have. So that is it. So P point to P prime, then Q prime to Q double prime, and then R double prime to R double prime. So you can be able to see this is the center of enlargement. Then triangle P triple prime Q triple prime R triple prime, the image of triangle P double prime Q double prime R double prime under a half turn about the origin. So there is half turn or a rotation of 180 degrees about the origin. So in such a case, then P double triple prime, so we have P double prime. So actually the image of, so this is a triangle, the image, so which is, this is minus 1.53, it is mapped onto to P double triple prime. So in that case, and since it is half turn rotation about the origin, then we should be able to get, actually they are going to interchange these values. Actually they will interchange the signs. Actually the signs is what will just be interchanged. So this will be 1.5, the other one will be minus 3. The other one is Q double prime triple prime will be 3 minus 1.5, and then R triple prime will be 3 minus 3. I hope that is clear. So we can be able to plot those points. So let us be able to plot these points. So the first one is P triple prime, that's 1.5 minus 3 there. Then Q triple prime 3 minus 1.5, and the other one is R triple prime, that is 3 minus 3. So that's the point. Therefore we join. So before we join, this is P triple prime, Q triple prime, and R triple prime. So we join those points. So that's how it will be. Fine. So that's how it will be. The other thing now is to describe a single transformation that maps this triangle P prime Q prime R prime onto P triple prime Q triple prime R triple prime. So from there, now join P prime to Q P double prime. So there's something you'll notice. So if you join them, they are meeting at a certain point, and that is the origin. That means there is an enlargement. It has enlargement, and the center is about the origin. So for us to describe it, we have to give the scale factor and also the center of enlargement as required. So in that case, so to get the scale factor, it will be either image distance over object distance. So in this case, this is our O, center of enlargement. So OP triple prime divided by OP double prime, I mean single prime, will be equal to, so change in the in our case here, this will be minus 3 change in y. So we take that 3 minus 3, and then in the x direction it has actually moved, that is minus. So that's what you need to consider. Either you are dealing with the x coordinate or y coordinate, you still get the same. So OP double prime y direction minus 3, for P prime is minus 2, so we get 1.5. So you can also try with OQ triple prime over OQ prime, and the rest will get 1.5. So this actually enlargement scale factor is 1.5 about the origin. So the center origin, the center is 0, 0. So that's how we do this particular question. So thank you so much for paying attention. Question 19. The following figure shows a right pyramid VABCD. The base ABCD of the pyramid is a square of side 8 cm. The length of the slanting edges VA is equal to VB is equal to VC is equal to VD, which is 10 cm. So calculate part A, the vertical height of the pyramid correct to 2 decimal places. Part B, surface area of the pyramid. And part C, the volume of the pyramid. So for part A, we need to find the vertical height of the pyramid correct to 2 decimal places. So to get the vertical height, so I need to join the diagonals of the base A to C and also B to D such that they meet at 90 degrees. Then I draw the perpendicular height or the vertical height. So let the diagonal meet at point O. Now, let me just extract from this. I have now I have point O, then I have C, and then V. So VC is 10 cm. Then we need to find the vertical height, and then OC will be a half of AC. But to get AC at this particular point, at B it is 90, so we can use Pythagoras theorem to get AC, then we get OC. So AC will be given by the square root of AB squared plus BC squared, which is square root of AB is 8 squared plus 8 squared. So we shall end up getting the square root of 128. 64 plus 64, that is 128. Using a calculator, get 11.31 centimeter. So we need OC. OC is a half of AC, and already we have AC, so that is a half of 11.31. So we are going to get 5.66 5 centimeter. That's for significant figure. Then now to get, so OC is 5.655 centimeter. So to get now of V, which is equal to H, will be square root of VC squared minus OC squared. And this will be square root of VC is 10, we square it, minus 5.655. We also do the squaring. So to be squared. So using a calculator, so you get this will be square root of 68.02, and therefore the square root of 68.02 will be 8.25, correct to 2 decimal places. Then part B of the question, calculate the surface area of the pyramid. So we need to get the surface area of the pyramid. In that case, whatever we need the area of the base, A, B, C, D, and then the areas of the slant faces. So base area, length by length, which is 8 times 8, we get 64 centimeters squared. Then we need the slant height to get, because the base is a square, that means all faces are equal. So we get the area of one face and then we multiply it by 4. So in that case, so if this is the one face, B, C, V, so that's the face I've chosen. I need to get this slant height of the triangle. So that's slant height of the triangle. This is 8 centimeters, so it's 4, and this is 10. So I can use Pythagoras theorem and I'll be able to get it. So 4. So to get, let me say this is M. So Vm will be equal to the square root of 10 squared minus, that is 4 squared. We shall end up getting, so 100 minus 16, that is 84. So the square root of 84 is 9.165 centimeter, and therefore area of one triangle will be a half base times height. Base is 8, then times height is 9.165. So we end up getting, that will be times 8 times 9.165, we get 36.66 centimeter squared. So area of 4 faces, 4 triangles, will be 36.66 times 4, which is 146.64 centimeters squared. Therefore, total surface area will be equal to area of base 64 plus the area of the 4 faces 146.64, then plus 64, that will add up to 210.64 centimeter squared. Then part C of the question, we need to find the volume of the pyramid. So volume is given by a half times base, a third times base area times the height. and that we mean perpendicular height. So we have a third. The base area, remember it's a square base, so 8 times 8. Then the perpendicular height, we got it as, in part A, we got it as 8.25. Therefore, if you use a calculator, multiply, we get 176 centimeter cube. Question number 20. Nema went to the market to buy bananas worth 2,100 shillings for school. The seller offered a discount of 3 shillings per banana, which enabled Nema to buy that 5 more bananas. Part A of the question. Taking X shillings as the price per banana before discount, write an expression for Roman 1. Number of bananas that Nema would have bought before discount. Roman 2. Actual number of bananas that Nema bought after the discount. Part B. Form an equation in terms of X and hence determine the actual number of bananas Nema bought. Part C. The bananas were given to students in a school. 2/5 of the students got 2 bananas each, while the rest got a banana each. Determine the number of students in the school. So, we need to answer part A of the question. So, if Nema went to the market and bought bananas worth a total of 2,100 shillings, and the seller offered discount of 3 shillings per banana, which enable Nema to buy 35 more bananas. So we take X as the price per banana before discount. So we need to write an expression for part 1, the number of bananas that Nema bought before discount. So the original number of bananas, that is before discount. So it will be the total amount divided by the price per banana, The total amount was 2,100 shillings, and the price per banana before the discount, it was X shillings. So taking before discount X shillings. So that is the expression for number of bananas before discount. Then Roman 2, actual number of bananas that Nema bought after discount. So price after discount will be X minus 3. That will be X minus 3. So number of bananas after discount, so it will be still the total amount, which is 2,100 divided by the price after discount, or can also be the other case. So remember, original number of bananas was 2100 over X. So the number of bananas after discount, so remember she bought that 5 more bananas, so will be the same as the original number of bananas, so which is 2100 over X plus 35. Either of these will be accepted. So those are the expression. We can move on to part B of the question. So part B of the question is, Nema went to the market, and still form an equation in terms of x and hence determine the actual number of bananas name about. So we needed to remember back from what we have done in part A, Roman 1 and 2. The original numbers of banana is 2100 over x, and the actual number of banana after discount is this amount, and this is what we are going to use in our second calculation. So the original minus this is the price after number of banana after discount is more by 35 the original, so that will be 2100 over x minus, that is the number of banana after discount, which is 35 more than the original number of banana, which is 2100 over x. If you subtract the two, it will be fine. Remember, it was 35 more bananas were bought. So from here, LCM of x and x minus 3, that is the LCM, is x minus 3. So we pre-multiply each term by the LCM. If we multiply this term by the LCM, we are going to get 2100 times x minus 3 will cancel, then minus the other one, x and x will cancel, so we have 2100 times x minus 3 will be equal to 35 times x minus 3. So you just open the bracket, so this will be 2100x minus, open the bracket, 2100x, negative this times negative this, plus 6300 will be equal to, open the bracket, that 5x squared minus that 5x times minus 3, that is 105x. So from here, this and this will be eliminated. So we have now 35x squared minus 105x minus 6300 is equals to 0. I'll just rearrange them. So I can simplify, divide it through by 35. So this will be x squared minus 3x. This will be minus 180 will be equal to 0. So I need to solve for x, and I'm going to use factorization method because it is easier to use it. So product of AC, so the product is, so the factors is 1 times minus 80 or minus 80. So I get factors of minus 180, such that when I add them I'll get minus 3. So, and in that case the factors will be minus 15 and 12. If I try to add minus 15 plus 12, I'll get minus 3. So I'm going to rewrite this quadratic equation, but the middle term being expanded, the expanded form. So this will be x squared minus 15x plus 12x minus 180 is equal to 0. Then I take into pairs, and then I factor out what is common. In that case, the first part, x is common, so I factor x out. Then I'll have x minus 15. Then the second part, 12 is common, so plus 12. So 12x divided by 12, I get x. Then minus 180 divided by 12, I get minus 15. Will be equal to 0. So this will be x plus 12 multiplied by x minus 15 is equal to 0. So either x plus 12 is equal to 0 or x minus 15 is equal to 0. Therefore, x is equal to minus 12 or 15. The number will be, x will be 15. X will be 15. So the question is, we solve, find in terms of x, hence determine the actual number of bananas Nema bought. So the number of bananas, so x is 15. So the actual number of bananas that Nema bought, number of bananas, actual, that is before discount, be 2100 over x, and that is 2100 over 15. Therefore, we end up getting, we have 140, then 140 after the discount, actual number. So after the discount, he was able to buy 35 more since he was given discount. So plus 35, so we end up getting 175 bananas. Then we go to part C of the question 2020. The banana were given to students in a school. 2/5 of the students got 2 bananas each, while the rest got a banana each. Determine the number of students in the school. So since we don't know the number of students, we can say let the number of students be maybe n. So if the number of students are n, therefore it means 2/5 of the student got 2 bananas each. So 2/5 of the student n got 2 bananas each. So times 2, the number of bananas each got, then plus the remaining fraction, which is 3/5, got, each of them got 1 banana. So 3/5 of the students times 1 banana each got. And remember, the total number of bananas we got was 175. 175, the total number of banana original after the discount, that is 175. Therefore we work it out. This will be 4/5n plus 3/5n is equal to 175. So 4/5 plus 3/5, that is 7/5. N will be equal to 175. So n will be 175 times 5 divided by 7. So you should end up getting 125. Therefore it means the number of students in that school, there were 125 students. Question 21. The end of term test scores of 100 students were recorded as shown in the following table. That is the scores, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and their corresponding number of students in each course. Then part A of the question, we need to state the model class. Part B, calculate the median score. Then part C, on the grid provided, we represent the above data. Using a histogram, and then use the histogram to determine the number of students who scored from 71.5 to 76.5. So we state the model class. So model class is the most repeated class, the most repeated. That means the class with the highest frequency. So in our case, if you look, the one with the most number of students is 32, but the class is 60 to 69. So that is the model score. Most of the students were able to score between 60 and 69, the model class. Part B, we calculate the median score. For us to be able to calculate the median score, so we need to get the median position, and we get median position is normally a half of n, or n over 2, but there are how many number of students? There are actually 100, so that will be 100 over 2, which is 50th position. 50th position. So that is the position of the median position. Then, using the formula, median is given by the lowest boundary, class boundary, plus n over 2 minus cumulative frequency, the median class, divided by frequency in the median class. This is cumulative frequency preceding the median class, then times the class interval. So for our case here, first we need to indicate cumulative frequency. We can have a row, and we get the cumulative frequency by adding the corresponding frequency, that is the number of students. We have 8, then 8 plus 10, that is 18, 18 plus 28, that is 46, 46 plus 32 gets 78, 78 plus 12, that's 90, then 90 plus 10, that is 100, must be equal to the total number of students. Then lower class boundary, so we need to identify the median position. So the position whereby we have 50, so 46, 50 is not included, so where we have 78, so this is the median class. This is the median class, 60 to 69, and therefore lower class boundary, the median class between 59 and 60, so it is 59.5, then plus 100 over 2, that is 50, minus cumulative frequency preceding the median class, it is 46, comes before the median class, then divide by frequency of the median class, which is 32, then times the class interval. So we get class interval 40 minus 30, or 50 minus 40, that way we get 10. So this will be 59.5 plus 50 minus 46, that is 4 over 32 times 10. So we end up getting 60.75. So that is the median score. Then we move on to part C. On the grid provided, represent the above data using a histogram. So for histogram, we normally plot frequency against the upper class boundary, and for the upper class boundary, in our case here, it will be 39.5, 49.5, 59.5, 69.5, 79.5, then 89.5. And frequency want to use 8, 10, 28, 32, 12, 10. So the maximum is 32, and so if we draw and it reaches 40, no problem, it will be alright. So just take the ruler and then we draw. Also draw the y-axis. Now from here 0. So for the y-axis, can use 2 big square to represent 10. So 10, 20, 30, 40. That is the frequency, or in other words, number of students. Then the x-axis, since we have the scores from 30 to 39, we use the upper class boundary, so we have 39.5, but the previous one was 29.5. so even without breaking, we can say let our y-axis to start from 29.5, but if you also break the axis, there is no problem. So 29.5, then 39.5, then 49.5, then 59.5, then 69.5, then 79.5, and lastly 89.5. So that is okay. Remember the reason why in the first part we have 29.5, and you can see here we have 30, so the previous upper class boundary was 29.5, and that's why we have it here. So this is upper class boundary. That's so important. Then the other thing is, now we need it to plot. So between 29.5 and 39.5, the number of students, now the frequency is 8, and one small square represents one student. So from here we can see the first one is 8, so we have 8 from here, 8. Then the other one, 39.5 to 49.5, it is 10. So draw the histogram there. That is clear. Then from 49.5 to 59.5, it is 28. So from here our 28 will be at that point. Then from 59.5 to 69.5, frequency is 32, so 32 will be at that point. Then 69.5 to 79.5 is 12, so at 12 this particular point. Then lastly 79.5 to 89.5 is 10. Now that is okay. So this is the histogram we have drawn for the above data represented. So we can move to next part, which is part D. Part D. Use the histogram to determine the number of students who scored from 71.5 to 76.5. So we want to see from 71.5 to 76 is between 69.5 and 69.5 and 79.5. So in other words, the number of students, so the number of students will be equal to the class width divided by, so since we have a uniform class interval, so divided by the class interval, then times the number of frequency in that particular rectangle bar. So the difference class width is 76.5 minus 71.5 divided by the class interval. I've seen the class interval is 10, 10. So times the frequency in that particular bar, the frequency is 12. So 76.5 minus 71.5, we get 5. So over 10 times 12. So we end up getting 6 students. So the number of students who scored between 71.5 to 76.5 is 6 students. Question 22. The following figure shows a quadrilateral PQRS and a circle passing through the vertices PR and S. Lines PQ is equal to PR is equal to 2.7 centimeter. PS is equal to 6 centimeter and SR is equal to 7 centimeter, and angle PQR is equal to 65 degrees. So you need to calculate length QR need to get length QR, then angle PRS, we need this angle, also required, and then determine the area of the circle. We need to determine the area of the circle. So let us begin with this part, QR, triangle PQR, so that we get length QR. We are going to use the sine rule. So let me consider this side QR is opposite vertex P, so let me use this is small p, and then we have R, this will be small r opposite to vertex R, and this Q opposite to vertex Q. So using the sine rule, we need to find length QR. We already know this angle 65. Also the other angle will be 65. Remember PQ and PR are equal, so this will be 65 degrees. Therefore, this angle here will be 50. So 65 plus 65, that's 130. 180 minus 130, 50. So P over sine P. So P is the side. P over angle sine P, angle P will be equal to, so any other value that is known, we have angle at Q, so on this side, so Q side Q over sine Q. So P, we don't know P, and that's what we are after. So P will be given by Q over sine Q times sine P. Therefore, P, which is equal to QR, will be given by, so Q, said Q is 2.7 all over sine Q, Q is 65 degrees, so sine 65 degrees times sine P, P is 50 degrees, so sine 50 degrees. So this will be 2.7 times sine 65. Using a calculator, you get 0.9063. Then times sine 50 using a calculator is 0.7660. Therefore, if you are out using a calculator, you get 2.282 centimeter. Even to for significant figure, to once one decimal place will be 2.3, and that is the length of QR. Then we move on to part A, Roman 2. We get angle PRS. PRS, this angle, that's what we require. So we are going to use cosine rule, and therefore from here, so since this side is opposite vertex R, we call it small r, is equal to 6 centimeter. Then this side is opposite vertex P, so P is equal to 7 centimeter. And then S is vertex X, PR is opposite vertex X, so this will be S is equal to 2.7. So I hope that is clear. So in that case, whatever we are looking for, angle R, that's what we are looking for. Therefore, we have side R squared will be given by, will be equal to the other two sides, the square of the other two sides. So P squared plus S squared, then minus 2PS cosine the angle that is to be found R. So R, we know it is 6, so that will be 6 squared times P. P is 7, so 7 squared plus S is 2.7, we square it, then minus 2 P times P is 7 times S is 2.7 cosine R. Therefore, so this is 36, will be equal to 49 plus 2.7 squared, that is 7.29 minus, so 7 times 2 times 2.7, that is 37.8 cosine R. So we move on. So from there, we have 36 is equal to 49 plus 7.29, that is 56.29 minus 37.8 cosine R. Therefore, subtract 56.29 on both sides, that will be that 6 minus 56.29, which will be minus 20.29 will be equal to minus 37.8 cosine R. Divide both sides by minus 37.8, so that will be cosine R will be equal to minus 20.29 divided by minus 37.8, which is equal to 0.5368. Therefore, R will be cosine inverse of 0.5368. Therefore, we shall get angle PRS, which is equal to angle R, is 57.53 degrees. Then the last part is to determine the area of the circle. So, before even we get to the area of the circle, then we are required to find the radius. We need to know the radius of the circle. But how can we be able to get the radius of the circle? How? So that is something important we need to know or get. So if that is the case, then we are going to use the sine rule, which will help us to get the radius of the circle. So for sine rule, we know that from here we can have this side PS. We also have SR, whichever will be much applicable with the corresponding angle. So in our case, we can be able to deal with R, so we know the angle R, and then this side is opposite it. So remember that for sine R over sine to R will be equal to 2R, whereby R is the radius of the circle. Even if we try with S, in our case with S also, we'll still have to get the same result. But whatever we have, we can easily deal with this since we have the angle R. So sine R, so I mean this will be R, not sine R, that will be R. Side R is the side R will be opposite angle R. Therefore, R, which is side PS, 6 over sine R, previously we got as 57.53 will be equal to 2R, where R is the radius of the circle if circle was to be drawn on it. Then therefore R will be equal to 6 over 2 sine 57.53, and this we end up getting 3.556 centimeter. Therefore, to get the area of circle, which is pi r squared, so we shall get over 7 times the radius 3.556 squared. So we end up getting 39.74 centimeter squared. So that is the area of the circle. Question 23. The displacement x meters of a particle moving along straight line after t seconds is given by x is equal to t raised to 3 over 3 minus 3t squared plus 9. Part of the question, determine Roman 1 the values of t when the particle is momentarily at rest. Roman 2 of part A, the values of the displacement x meters by the time the particle comes to rest. Then part B of the question, determine the values of t when the velocity of the particle is minus 5 meters per second. Then part C, determine the acceleration of the particle at t is equal to 2 seconds. Therefore, if the displacement of a particle is x meters from moving along a straight line t seconds, so it's given by, so displacement x is equal to t cubed over 3 minus 3t squared plus 9. So what we need to know that when the particle is momentarily at rest, then at rest the gradient function, that is of displacement, differentiation of displacement with respect to time, is given by, is actually equals 0 at rest. It is 0, or we say at the turning point. That's at the maximum height. So dx dt will be given by, we differentiate what we have. So if we differentiate this, it will be 3. So we have t raised to 3 over 3. So when differentiating, we multiply by the power, and then we reduce the power by 1, then minus the other one, we have 3t squared, so we multiply by the power, so times 2, and then we reduce the power by 1, and lastly then you have plus, so 9, this is the same as x raised to 0, so that will be 0 times 9, then x raised to 0 minus 1, so everything multiplied by 0 is 0, so therefore we are going to have, this will cancel, so we have t raised to 2, then the other one will be minus, so 2 times 3 minus 6, t raised to 1. The other one is 0, so that is the gradient function. And they are saying that at rest the gradient function is equal to 0, therefore this will be equal to 0. So we can factor out t, so we have t minus 6 will be equal to 0, either t is equal to 0 or 6. So from the starting point, so after 6 seconds, the particle, after t is equal to 6 seconds, because the initial starting point t was 0, so after 6 seconds, then the particle will be momentarily at rest. Then Roman 2 of the question, the values of the displacement x meters by the time the particle comes to rest. So displacement, so after when t is equal to 0, because that is when the particle is at rest, so when t is equal to 0, displacement x, we substitute into the equation of displacement. So when t is 0, so that is 0 cubed over 3 minus 3 times 0, so that is 9 meters. And when t is equal to 6 seconds, so the displacement will be 6 cubed over 3 minus 3 times 6 squared plus 9, so this will be 72 minus 108 plus 9, whereby we get minus 27 meters. So that is in the opposite direction. Remember, displacement is a vector quantity, so it is in the opposite direction. Then part B of the question, determine the values of t when the velocity of the particle is minus 5 meters per second. Remember, for displacement, we have that is t cubed over 3 minus 3t squared plus 9, and therefore dx dt, we got it as t squared minus 6t. So displacement, and this is actually the velocity. So when dx dt is minus 5, so t squared minus 6t is equal to minus 5. So this is the same as t squared minus 6t plus 5 is equal to 0. I'm going to use factorization method to solve for this quadratic equation. So the product AC, 1 times 5, that is 5. Then I look for factors of 5 such that when I add them, I'll get minus 6. And the factors I have minus 5 and minus 1. So I write the middle part or term in the expanded form. That will be t squared minus 5t minus t plus 5 is equal to 0. Therefore, I take into pairs and I factor out what's common. So in the first part, t is common, so factor out, I get t into bracket t minus 5. Then the other part, 1 is common, so I get t minus 5 is equals to 0. Therefore, this will be t minus 1 multiplied by t minus 5 is equal to 0. Therefore, t is equal to 1 or 5. So, when the particle is minus 5 meters per second, it's after 1 second or 5 seconds. And then lastly, part C of that question, 23, determine the acceleration of the particle at t is equal to 2 seconds. Acceleration of the particle, we have to differentiate velocity. So remember, acceleration is given by dv dt. But remember, we had dx dt, which was t squared minus 6t. So actually, now this, we need to differentiate it. Differentiate it again so that we get this value. So dv dt, so need to get to differentiate this again, and I will get this will be 2t minus 6. Therefore, at t is equal to 2 seconds, 2 times t is 2 minus 6. So this will be 4 minus 6, which is minus 2 meters per second squared. And that is the acceleration of the particle at t is equal to 2 seconds. So question 24. In this question, use a ruler and a pair of compasses only. So we expect to use a ruler and also pair of compasses only. So line PR, so this is actually PR, not Q. So PR is 6 centimeter. So we are required to locate PR is diagonal of a quadrilateral PQR. Yes. and PR is 6 centimeter. Then we are required to locate vertex Q of the quadrilateral PQRS such that angle RPQ is 60. So we are going to draw an angle of 60 degrees at P, and then angle PRQ at this point also we draw an angle 45 degrees. Then we complete triangle PQR and ends measure PQ. Then part B, diagonal QS, which is 10 centimeter, intersect with diagonal PR at right angle. Complete the quadrilateral PQRS. Then calculate the area of the quadrilateral PQRS. So from here, what we are required, so already we have been given the length PR, which is 6 centimeter. So we need to construct an angle of 60 degrees at P. So we use a compass. So we have a compass here, and that's what we are going to use so that we actually plot an angle or construct an angle of 60 degrees. So in that case, I'll just adjust the length of the compass, the radius. So I use, and then I put a mark. Then from there, I also move the point of the compass to this side, and then I also maintain the same radius and put an arc there. So once I do that, I am going to use a ruler to join the point P and the intersection of the axis. So in that case, so let me use this. I join the points, point P and the intersection of the axis. So once I join, so let me join. So I have joined that point. Then, so this angle is, 60 degrees. Then at R also I'm going to construct 90 degrees first, then from there bisect it to construct an angle of 45 degrees. So in that case, it will allow me just to extend this PR at R. So I extend it outwards. Then from there, I'll be able now to construct a perpendicular angle, or an angle of 90 degrees. So for I to construct an angle of 90 degrees, I required to make an arc this side, and also on the other side I put an arc. Then from there, now I'll use the pointer at this point. The arc I've just made, then I put an arc at the top and also below, maintaining the same radius. I place the pointer of the compass at that particular point. Then I also put an arc at the top and also at the bottom. Then I take a ruler and then I draw that vertical or the perpendicular line. So to the perpendicular line, that point. Once I do that, I take the compass again and then I now bisect the angle. Now I bisect the angle. First I put those two marks there, and then I adjust the radius and use the arc that I have made on line PR and the perpendicular. So just adjust it. I make an arc there, and also I use the other side as the center, the radius. I put an arc there. Once I do that, I take the ruler. So I'm going to construct or draw the line so that it joins. So that is the point where they intersect, that is the point. The other point, Q, it will be Q. So this will be point Q. So this angle we have drawn, constructed, is 45 degrees. Then from there, we have located the vertex Q such that this angle is 60 degrees and this one is 45 degrees. So the other thing is, we have been taught diagonal QS, which is 10 centimeter long, intersect diagonal PR at right angle. Therefore, we are required to, it's perpendicular, so it cut PR at right angle. Therefore, we need from Q, we are going to draw a perpendicular line downwards. So if we do that, so from Q, I mean, we draw perpendicular. So from there, you can plot the perpendicular line. The perpendicular line. So from here, I draw that line first. Then after that, I put an arc down there. From what I just maintaining, I can still try to maintain the same radius, or I just adjust it. There's no problem. So using this as the center, the arc, I draw an arc there. Also, the other arc side, I use it as the center, and I draw the arc at that particular point. Then once I do that, I take a ruler and join, draw that line from Q downwards. And since QS is 10 centimeter, therefore I'm going to measure from Q a length of 10, and then I put the arc 10 centimeter. So that is 10 centimeter. So that's where it is, and that is S. Therefore, from there, now I'll join RS. I'm going to join RS. So you join RS. then P to S once I do that. Now another thing that we need just to consider is to answer the question as required. Part A, we actually located the vertex Q, and afterwards we complete triangle PQR, and hence we find length PQ. So what will be length PQ? PQ will be what? So length PQ, just take the bus and let us measure it and see the value you are going to get. So I'm getting 4.4, that is 4.4 centimeter. Then the other value we are going to get, QS was actually 10 centimeters, that's why I've just written it there. So that is PQ, and then we have completed the quadrilateral and it can be seen. Then calculate the area of quadrilateral PQRS area. So for the area, it will be area of triangle. We can just subdivide them into two triangles such that PQS plus area of triangle QSR. So that is in order. So the only thing we need to know from the perpendicular bisector QS, let us say it is meeting cutting at M. So PM will be what? So value of PM and also the value of MR will be what? So from here, I want to measure Q, so that will be 2.2, that is 2.2 centimeter, and then MR will be 3.8 centimeters, such that in total it will be 6 centimeters. So the area will be a half. Base for this triangle, the base is 10, then height is 2.2, and then plus the other one is a half times base is 10 times the height from M to R, which is 3.8 centimeter. So for this one, this will be 11 plus the other one will be 19. So if we add, we get 30 centimeter squared.